Hey everyone, welcome to the networking module of our Azure Masterclass v3. Hence this is a TCP joke. Did you get it? Did you get it? Did you get it? As opposed to a UDP joke, you may not get it. But the goal of this module is to look at the basics around what is a virtual network, its core capabilities in Azure, some of the connectivity choices we have in terms of maybe connecting virtual networks together, but also connecting virtual networks to on-premises, and then controlling the traffic, viewing the traffic, capabilities like that. Now, if we dive into the basics around a virtual network exists within a specific subscription and within a specific region. And so it cannot span subscriptions, it cannot span regions. So if we think just from the real basics, if I have the idea that we know we create that subscription, and remember the subscription is really that fundamental initial building block and boundary for the various security billing capabilities we have. And then from within a specific subscription, we then have the ability to use one or more regions. So here we're then leveraging a specific region. And so our virtual network that we create lives within that specific region we've selected and within that specific subscription. So it lives within a region, lives within a subscription. It cannot span them. So we go and create our virtual network. Right there. So this is our particular VNet. So we call this VNet 1. So we have this object for which we can then go and create things. Now, within this virtual network, it's going to be made up of at least one IP range. Now, initially, this IP range is going to be IPv4. So we're going to have a certain range of IPs. We say CIDR, a CIDR block, a contiguous block of IP addresses. So we'll say it's CIDR block 1. But I can add additional ranges. So I could go and optionally add another range completely. I can remove them as well. If it's empty, there's no subnets in it, I can go and then remove that particular IP range from the virtual network. And what I will then do is I will break this virtual network up into subnets. So I might think about, okay, I'll take a certain portion of that range and I'll create one or more subnets within it. So here you can see this could be subnet 1. And it's a portion of one of the ranges assigned to it. So this is a subset. We'll say this is CIDR 3. And I've got another subnet, CIDR 4. And obviously they can't be the same IP ranges. I can't use the same IP range multiple times on multiple subnets. So I'm just breaking up these IP spaces into subnets to which I'll then use for various resources. So as we can see here, I've got one or more IP ranges, and we can actually jump over to the portal and see this super quickly just to reinforce. So if I actually jump over and we look at our virtual networks and we create one, the key things we'll see as always is where it has to live in a certain resource group, it's living within a certain subscription, and I have to create it in a specific region. So those are those boundaries that we were talking about. And then there are some various security things we can do, but we pick the IP ranges. And you can see by default, it's just picked this particular IP range, 10.0/16, and it's created a default subnet as well, which is a subset of that, a /24. So that's using 8 bits for the subnet. So I get that many ranges, 256 addresses within there. Now I could add additional subnets. I could delete this default subnet. I do have complete controls over this. Notice it's giving me the option to add additional IPv4 or IPv6. And we'll actually come back to that in a second. But I can go and customize the various address spaces that make up the virtual network. And as mentioned, I can even go and modify it post creation time. So that's some of the key basics around the idea of the virtual network. Now, typically what's going to happen is you're going to use RFC 1918. So RFC 1918 is a set of IPv4 address spaces that is not routable on the internet. So the goal is we will use those for our intranets, so we're not wasting IP space. And because they're non-routable, different companies can all use those same addresses within their internal networks because they can't conflict with saying, maybe I want to go and talk to from the network. So that's the 10/8, the 172.16/12, and the 192.168/16. If you look at your home machine and you've got a home provider for the internet, nearly always it's probably going to be a 192.168 or a 10 dot something or 172.16, for example. So you'll see those a lot. And then as a company, when I want to go and talk to the internet for the devices in my organization, there's some kind of network address translation, NAT, which is where I have some services that sit on the edge of my intranet that do have internet routable addresses and do the translation, act on behalf of the clients inside, so they can all go and communicate. Now, you don't have to. You could use non-RFC 1918. You might have a whole block of public IP space, and you want to just bring that into Azure, but realize it still wouldn't be internet routable. Even if I brought internet addressable IP ranges and used them for my virtual network, so I had some public range here, they would still be treated as private IP space in Azure. They would not be contactable and routable out to the internet. There are some IP ranges you can't use because they're reserved for various Azure functions, and they're all outlined in the actual documentation. And then, as I mentioned, you break up that IP space or spaces on the virtual network into one or more subnets. Now, when you do this, you do lose a number of IP addresses because Azure and the IP protocol in general use a number of those IP addresses. So you might say, oh, I use a /24. And actually, let's go and look and see what it does. So if I was to just go and look at one of my virtual networks, for example, and we'll look at the subnets, you can notice these are /24, and these are empty, but there's only 251 available IPs. Remember, that's normally 256 addresses, but I've lost 5, which is what always happens. You always lose 5 IP addresses. This is because you always use the first and the last as part of IP. So if it's all zeros for the host part, that's the network address. If it's all ones, that's the network broadcast address. So if I had a common /24, that would be the .0 and the .255. And then Azure reserves the first IP address, for example, .1, for its default gateway, and then it reserves the next 2, i.e. .2, .3, for Azure to map to the Azure DNS spaces. So you always lose 5 addresses. Now, if I was using IPv6, they are always a /64 in size. IPv6 is 128 bits. It's huge. The goal is, I think there's millions of IP addresses for every square foot of the earth, so we shouldn't run out of those. But for compatibility with like on-premises routers, for example, and because the address space is just so huge, a subnet is always /64 in Azure. At time of recording, you can have 3,000 subnets per virtual network. And again, I can resize these things, providing they are empty. Now, sometimes when you look at a subnet, you'll actually notice it says delegated to a certain service. And what that means is that subnet is really just a marker, but it means it's going to be exclusively used by some service. There are a number of Azure capabilities that will either integrate or inject themselves into a subnet in your virtual network for a tight integration. but it wants exclusive use of that. So if you ever see a delegated to within one of your subnets, it's because a certain Azure service is using it, and it means you can't put your own stuff into that. And then what happens when we are actually using these things is you connect resources to it. Now, you don't really put things into the subnet. If we think about, okay, there's my virtual network. Imagine I create some resource. So for example, I was to create a virtual machine. So I'll create a VM resource. And then one of the other resources that a virtual machine will have is a virtual NIC, a network interface card. And what happens is I then connect that virtual NIC to a particular subnet. So I'll connect this NIC to that subnet, and as part of that connection, there is now a configuration. So this says, oh, okay, this is connected to VNet 1, and it's connected to subnet 1. So that's how we can use resources with a particular subnet. It just works that way. Now, many resources can actually have multiple virtual NICs. Each of those NICs can have multiple IP configurations, but they all have to be within the same virtual network. So for example, I might have another NIC here that connects to this subnet, but what I can't do is have another NIC and connect it to a completely different virtual network. It does not let me do that. And you might wonder, well, why would I want this? Imagine I had some kind of network virtual appliance. Well, that network virtual appliance may want hooks into different subnets because maybe one of them is like a front-ended DMZ. One of them is then considered more of an internal network, and it can then bridge the gap and it can route between those things. If we were to look, just jump over quickly, we'll see that configuration when we look at a network interface card. So if I look at a virtual machine, if I go and look at the networking, what's really happening here, actually maybe a better view, if we look at the resource group, we can actually see there is a separate network interface resource. So it's its own resource, and there's that NIC that's being used by this particular virtual machine. And if we look at the network interface card, well, then we can see, hey, it's actually connected to this virtual network and this particular subnet. And then we can see, well, it's got this private IP as part of its IP configuration. And then this one actually has a public IP address as well, which is an optional thing we can have. And this one even has a private IPv6 address, but not a public. So we can see we have these idea of multiple different IP configurations available to the resource, but it's the NIC that connects to the subnet, and then the NIC connects into that virtual machine. Now, one of the other key points here is, remember we talked about in the resiliency class, regions have availability zones. So a subnet is a regional construct and actually spans availability zones. So I don't have to link a particular subnet to a particular availability zone. It does not work that way. So if I think about, well, this is the region, and now imagine, for example, well, yes, as part of this region, it has availability zones. So there's an AZ1, there's an AZ2, and there's an AZ3. The subnets span them. So there is no hard linking of a subnet to a particular availability zone. So I could have resources, for example, VMs live in AZ1 and AZ2 and AZ3, all within the same subnet. There is no hard linking between those different constructs. Now, for the virtual machine NIC, as we kind of saw already, the IP address for the resource always comes from the Azure Fabric. So as a guest operating system, it's leveraging DHCP. So the NIC of the virtual machine shouts out over its network, hey, I need network information. That's normally a broadcast. Now, we can't do broadcasts in Azure Virtual Network. This is all software-defined networking. So what actually happens is when it does that shout out is actually captured by the software-defined networking components of Azure. It looks at the configuration of the virtual NIC and then returns it the required information. So it would return it, here's your IP. And I could, if I wanted, make sure it always gets the same IP. Here's the gateway. Here's your DNS config. Here's your subnet mask. Now, there is an exception to that. If I do assign multiple IP addresses, for example, well, then I do have to go and perform manual configuration. On Windows, I would have to go and configure the primary and the secondaries. For Linux, it would only be the secondaries I have to configure. As mentioned, I can reserve addresses, but I still would not ordinarily configure it just as static within the virtual machine. Instead, as part of the configuration of the NIC, I could go in and say, hey, I want this to be static. So in this case, I'm looking at the network interface. If I go to the settings, I have IP configurations. So we're going over to the settings, looking at its IP config, and I can have multiple IP configurations. You can see that already. So what I have right here is, you can see I've got two. So I've got one IP configuration, which is the primary, and that one is always IPv4. And you can see right now the IP address is dynamic, i.e., if I shut this VM down and then started it again, there's a chance this IP address would change. And we can see I've also got a public IP address assigned. And then I have a second IP configuration where it's getting an IPv6 because I enabled this VNet and the subnet for IPv6. But I could change this. I could select my IP configuration, and notice for the private IP address settings, it's currently set to dynamic. If I changed it to static, I would then just tell it the IP address, and then it would always be given that. So it's like doing a DHCP reservation in a way, but it's letting the Azure Fabric actually handle and perform those things. So I absolutely have those capabilities to do that as required. So IP address is always coming from Azure. Now, as mentioned, I can add multiple NICs. Now, the exact number depends on the size of the virtual machine. I can attach and detach those through the portal, through the CLI as part of my configuration. But one important thing to remember, this is all software-defined networking. There isn't actually a physical NIC on the VM that's physically attaching to a unique piece of wire. These are all software-defined networks. They're using network security groups, they're using routing. And so most of the time, the reasons you had multiple physical NICs in the real world is because I had to connect to different physical cables because they connected to different physical ports that connected to different physical VLANs, segments of my network. It doesn't apply in Azure. And so most of the time, the arguments for multiple NICs just don't work the same way because it's all software-defined networking. But maybe I do have that virtual appliance and I do want them to connect into like a front-end subnet and a back-end subnet to do certain routing. It could be useful in that perspective. But again, it can be in different subnets, but has to be in the same virtual network. Many virtual machine types support something called accelerated networking. Now, ordinarily, the capabilities are the hypervisor, where it's performing and creating these virtual network interfaces. The traffic passes through a virtual switch, which looks at what are the rules that should be enforced, looks at where the packets should go. So it introduces a bit of latency there. What happens when I use accelerated networking is it's essentially bypassing that network switch within the hypervisor, and instead it's using capabilities of the hardware to expose something called a virtual function. Think of it like a virtual NIC that's been exposed through the hardware directly into the virtual machine, which means it doesn't have to go through that virtual switch. It's plumbed directly through. Now that hardware within the Azure host still supports things like the routing, the network security groups. They've done all of the work there, but it will reduce the latency. I can get enhanced performance through there. So this accelerated networking is a great thing. It's supported on a lot of different types of virtual machine. And if we actually go and look at this for a second, what you're looking for is when you look at a virtual machine, so I'm looking at the DE SV6, you're looking for accelerated networking to be supported. That's how you can check, is it going to support it? Now today, most of the modern VMs, if it's got more than 2 virtual CPUs, if it's hyper-threaded 4 virtual CPUs, it should support it. And generally, it's nothing but goodness. And so if you see this available for the virtual machine, go and turn the thing on. It doesn't cost you any extra money. Now, it does look a little bit different within the guest operating system. So just go and check on that. But it's nothing but goodness for the most part. You'll also hear something called Azure Boost. Azure Boost, again, is special hardware to accelerate various types of things. It can accelerate storage performance, it can accelerate security, it can accelerate networking. So the Azure Boost has something called a Microsoft Azure Network Adapter, MANA. And that actually supports up to 200 gigabits per second through that special MANA network adapter. Now that is in preview right now. I think it's going to roll out over time. It will become probably a new standard. I think today it's only the DV6 and the EV6 have it, both for Windows and Linux. But that's, I think, the next stage. We have accelerated network, which is very broadly available. And then the Azure Boost, which has a lot of these FPGAs, these special pieces of hardware in the hosts. Those are just going to make things even better. As mentioned, you can have multiple IP configurations per NIC, which we showed already. So you're always going to have, the primary configuration will always be IPv4, which can optionally have a public address. But then I can add secondary IP configurations that can be another private IPv4 and optionally a public IPv4. I can also add a single IPv6 secondary private IP configuration, which itself could have also a public IPv6. But I can only have one of those configurations per NIC. Now, you may be wondering a little bit like, well, why do you bother with these things? Like, why do I care maybe about having multiple IP addresses? And one of the reasons could actually be that with each IP address, remember, with the IP protocols, we have a whole set of ports that we can talk to. And so I get a certain number of ports per IP address that I can use. So if I was running some kind of workload that had many clients talking to it, well, each client would talk to a certain port, a unique port combination for that. And so I may max out what's available with one IP address. Think something like network address translation. So one of the benefits of multiple IPs is, well, I get multiple IPs, so I get multiple sets of these ports. So I could scale the ports, I could scale the number of maybe clients and services I can actually talk to. So that's one of the reasons you would actually see that in action. So that's what I just talked about. So what are the supported types of traffic? Now, obviously, the big ones are going to be, it's layer 3 is the key part here. So it's IP and above really run on your virtual network. TCP and UDP, they're the big ones you always have to have. Like everything major regular communication is going to be TCP or UDP. Remember, TCP, the joke here is that it checks, hey, did you receive this packet? It will resend. Whereas UDP is just kind of fire and forget. It sends it out, but it doesn't care if it was received. It doesn't check those things. So that would be the responsibility maybe of the client to go and re-request and handle that. So you have a choice of, do I want a more stable, checked form of traffic, or I just want to fire it out, pretty higher performance, but then there's a risk packets get lost, they're not received, and something else has to handle that. ESP, the AH, they're part of IPsec. So they're the encryption and the integrity capabilities. And then you'll see ICMP. So ICMP is used for diagnostic type functions. We use it for the echo request. So every time you type ping to say, hey, is something there? If I'm using a trace route, that's using ICMP to validate that. Now realize they're the things that are talked about as supported types of traffic on a virtual network. Other layer 4 protocols may work. However, as soon as you start interacting with other components, think the load balancer, think network security groups, well, they only understand specific protocols. So while another type of layer 4 traffic that sits on IP may work, you also may be going to get varying functionalities, because as soon as it has to go through a network security group, or it hits an Azure Firewall, or I try and go to a load balancer, it may completely fall apart. So this is really the types of things that I can leverage as part of my virtual network. Things that definitely won't work, multicast. So multicast is I'm going to talk to multiple different things as part of the communication. That doesn't work. Broadcast, where I kind of shout out to my local subnet, hey, I need an IP address, hey, I'm changing something. Those don't work. Network virtualization, so the generic routing encapsulation, GRE, that's actually what Azure uses as part of its network virtualization. Those things are not going to work. If I, inside my virtual machine, try to use a promiscuous network sniffer. So promiscuous means it's just looking at the wire. It's like, ooh, what traffic is passing by? I'm going to try and capture that. It won't work. Your virtual NIC isn't really connected in a traditional sense to a wire that all the traffic is whizzing past. It's software-defined networking. There's intelligence that is looking at, well, which traffic is bound for this particular virtual NIC, and would send it to it. It can't see anything else. Now, if I was running a network sniffer inside the VM, I'd be able to sniff the traffic for my NIC. Sure, I'll be able to see that, but I can't see other traffic on the subnet that it isn't actually bound for me as a target. I can't deploy my own DHCP server in Azure for my Azure clients because, again, clients in Azure, when they do that broadcast, it just gets grabbed by the software-defined network. It would never get to a regular DHCP server that's listening for those, hey, I need help. However, previously, there was something called rate limiting for DHCP relay traffic. And what that really meant was I couldn't even host a DHCP server to maybe serve an on-prem set of clients. They have removed that restriction. So technically, what I can now do is I could run a DHCP server in a VM that could serve on-premises clients. Because what you would do is you would set up a relay. So the relay would send the traffic directly to the DHCP server, so it's not broadcast, so it wouldn't get captured. That relay on premises would talk directly to your DHCP server, so it would then be able to give it the responses because it would now be unicast, not broadcast. So that's one of the changes they did make. You cannot ping the Azure gateway. So whenever I want to talk between, for example, outside my subnet, I have to go via the gateway. So when I talk to things within my same subnet, I talk directly to them. As soon as I try to talk to something in a different subnet or a different network, really it's bouncing via things that have connectivity to both. So in a physical world, you have gateways, and the gateways have wires or VLAN configurations into the different subnets. Again, this is software-defined networking that doesn't exist. But there's still a gateway component that Azure is providing that when I try and talk to something outside of my subnet, well, it goes to the gateway, and this software-defined network gateway component then passes it on to the target resource in its target subnet. I can't ping it because it's not a real thing. I can ping between my services if the firewall within the client operating system allows the ICMP and those echo requests, but I cannot ping the gateway. So it's just something to understand. If I'm trying to check connectivity, pinging the gateway is not going to work. It's not real. Also, traditional layer 2 VLANs are not supported. On premises, we're used to creating VLANs. They sit below layer 3, they're layer 2. It just won't work in Azure. Azure is layer 3. everything is software-defined networking. So IPv6, virtual networks are dual stack. What that means is I can have IPv4 and optionally IPv6, but IPv4 is required. I cannot have an IPv6 only. So you're going to have, hey, my regular IPv4, and then I can go and add IPv6 configurations to it. So if I was to look, for example, because you saw it on this one, this is connected to, let's look at this virtual network. So if I look at the address space, what you can see here is I added an IPv6 address space as well. Now, ordinarily, you would probably see this would be actually a 48, but I actually split it so I could use this particular IP range, this IPv6, in multiple different virtual networks. So I split it further. But then when I actually now go to my subnets, as part of the subnet configuration, you can see it there, I can optionally enable IPv6. So I enabled it for this particular subnet. The size, as mentioned before, will always be /64. It's never going to be any different from that. So it has good compatibility if it was going to go and talk to maybe on-premises things, for example. And now, as part of that, when I have a virtual machine that's connected to this subnet, it will get both an IPv4 and an IPv6. But again, I cannot be IPv6 only. But hey, great, I can go and dual stack enable where I want that right now. There are various types of IPv6 address, just like we have different types of IPv4. We have IPv4s that are only used internally. We have IPv4s that are publicly routable. We have like loopback addresses. IPv6 has the same things. They're globally unique, which are internet routable. We have linked local, i.e. self-generated. We have ones that are non-internet routable, which is what I was doing there with that FD. So there are different types. And I did a whole video on IPv6, if that's something you really want to dive into. It is supported by a lot of the capabilities of Azure right now. So obviously a virtual machine and that VNIC, that supports IPv6. You saw, hey, I've got that IPv6 address. Network security groups, they are things that control what traffic can flow. Those support IPv6. User-defined routes, they're things that help me route traffic to particular next hops as part of its path. Those support IPv6. Azure load balancers to distribute traffic through a single front end and their health probes, they support IPv6. Peering, connecting virtual networks, they support IPv6. Private Link does not have IPv6 support right now. So just go and check exactly what it is you want before you say, oh, yes, I can use IPv6 as part of this complete solution. Now, obviously, because virtual machines support IPv6, things like virtual machine scale sets support IPv6, and because virtual machine scale sets support IPv6, AKS can support IPv6, but it really depends on the networking stack. So I think if you're using KubeNet, yes, I can use IPv6 in a dual stack. You're always going to hear the word dual stack. I always have to have IPv4 as well. The core Azure management plane, the control plane that these resources have to talk to is IPv4. So you're always going to have an IPv4. If you're using the AKS Azure CNI overlay, that can be dual stack. I think with Kubernetes 1.26.3 or something like that. And then the nodes and the pods get an IPv4 and an IPv6. They're dual stack. But then the services that use that could then just be IPv4 or just IPv6. So that's a service within the AKS. As mentioned, it can never be IPv6 only. I keep saying this over and over again. I can enable IPv6 on an existing resource. Whether it needs a reboot or not completely depends on the operating system. It depends on its current configuration for DHCP v6. And so different Linux flavors, for example, different distros respond very differently. but I definitely would not have to redeploy the resource. I may have to reboot it if I go and enable the subnet for IPv6, for example, but I would not have to go and redeploy my resource at all. ExpressRoute private peering does support IPv6. We're going to talk about this in more detail, but ExpressRoute is a way to have private connectivity between my virtual networks in Azure and my on-premises networks. All I need is a pair of /126 addresses for the primary and the secondary links I need for my ExpressRoute, and then I'll be good to go. And public IP addresses are IPv4 or IPv6. So if we go and look for a second, if I want to go and create a public IP address and do create, it's going to ask me, where's it gone? It will ask me, there we go. Which do you want? Do you want IPv4 or IPv6? So it's one or the other. It can't be both. So I want it to be IPv4 or IPv6 for when I want to head and create one of those addresses. External access is a very interesting one. And what we're talking about right now is internet, talking to the internet. There is no special demilitarized zone, a DMZ subnet in Azure that you have to put things in to be able to talk to the internet. Now, there is an implicit internet access for resources in Azure that are in a virtual network, i.e., I don't have to do something manual. If I'm in a virtual network today, implicitly, without me doing anything, I can talk to things on the internet. What's happening is, depending on the configuration, Azure is providing a public IP address. It's using port address translation to masquerade my private IP addresses. It then has some ephemeral ports that enable stuff to go and talk to the internet. It is always stateful. So even if I have access to the internet, it doesn't mean things from the internet can talk to my virtual network. I can get the response back. So I've gone and requested a web page, I can get the response, but it doesn't mean someone from the internet just can go and talk to my resources. We can control that flow of communication to the internet from the internet with something called network security groups with things like Azure Firewall. We're going to dive into these. But a key point here is this implicit access is actually going away. So if we look at the documentation for a second, and if as you're watching this, it may have already gone away, but this is what you care about. On September 30th, 2025, this default implicit access for new will be retired, and over time, other things will kind of go away. So what this is basically saying is you do not want to be using this implicit. Now, one thing you can do today, if I look at a virtual network and I look at my subnets, there is an option available on the subnet that makes it a private subnet. So if I check this box, what this does is it turns off that implicit internet access. So I can actually go ahead and do that today. So maybe I have a subnet. Now, again, I should be restricting stuff with network security groups and other capabilities. But the other thing I can do right now is, well, I can actually go and turn that off. So I can turn off that implicit access. But if I actually want to do an explicit method for things to go and talk to the internet, well, the best one is actually NAT Gateway. So NAT Gateway is specifically designed to provide outbound internet access. And the way this really works is if you think about, okay, so this is my virtual network. What I do is I create a NAT Gateway instance. So I create a NAT Gateway. And then that gateway has public IP addresses or prefixes, i.e. a set a contiguous set of public IP addresses. So this has public IPs. And now what I'm going to do is with this, I link it to particular subnets. So I'm going to go ahead and link this NAT gateway to one or more different subnets. And now anything in this subnet will just use this. There's a route table on the subnet. So the internet addresses will be now configured to use this as that hop. And what happens here is for every public IP the NAT gateway has, it provides like 64,512 ports per IP. And I can have up to 16 public IPs on it. So think of the scalability of this thing. It can support a massive number of clients actually going and talking to that. And I can link this to up to 800 subnets. Now, it has to be within the same subscription. So this NAT gateway lives within that subscription, and I can link it to subnets within the same subscription. The nice thing here is it's specifically designed for those outbound connections. And then maybe if I have other services that the resources are talking to, I'll know specifically which IP addresses I want it to allow traffic from. Whereas if I was using that implicit access, I don't know what public IP Azure is going to use to provide that. I couldn't do it. But here I know the specific IPs that communication would be coming from when I try and talk to some other internet-based service. Now remember, we shouldn't be relying just on IP address. We should also be using authentication. We think zero trust, we validate everything. We don't just trust the networking. But this could be a piece of that puzzle to only allow that communication if it's coming from that. And then I do the authentication and the other things on top of that. Another thing I could do is the Azure Load Balancer is a component that I use to distribute traffic to backend services. Well, if that Azure Load Balancer has a public IP address, it's a public as opposed to a private load balancer, it's providing services from the public to be able to go and consume within my subscription. Well, I can also create outbound access. So I can create specific rules. And if I add those outbound rules, then those resources can go and talk to the internet via the load balancer. So in this scenario right here, you can imagine, okay, something else I do is I'll go ahead and I'll create an Azure public load balancer. And what I've done is the front end configuration is a public IP. And then if I think about the resources, we imagine this particular one was added as part of a back-end set for that load balancer. As long as I have the right outbound rule defined, well, this resource would now go and talk to the internet via its public IP. And again, it's pretty good with the NAT ports it can leverage to give me a pretty good spread of addresses there. Other things I could do, and actually an important point here, even today, if I put a resource behind a private Azure Load Balancer, it won't be able to talk to the internet. It breaks the implicit access. I would have to then go and do something to expressly give it that set of access to the internet. I could give the instance a public IP address directly. Well, that's always an option. So on my picture right here, as part of this IP config, if I just added a public IP address to it, it would go and use that to talk to the internet. Now, we generally don't like resources having public IP addresses directly. I really want some kind of abstraction in between for many reasons. From a security perspective, I don't want things to be directly accessible from the internet. It's generally a sad day. But even if I was providing a service to the internet, do I really want that service provided by a single resource? What if it's going through maintenance? What if it fails? Generally, I would want multiple resources providing the service, maybe spread over availability zones, or maybe even I'm doing a geo distribution, and then those will be behind a load balancer. And that provides the service. And then if I'm using something like an app gateway or Azure Front Door, I can put a web application firewall in front of it to even give me better protection. So yes, this does give me internet access, but I generally don't want to give resources a direct public IP. It's just something that's really not that great as part of my my all-up configuration. It's generally a little bit troublesome. Okay. There are other things I could do as well. I could use Azure Firewall. So Azure Firewall, it inspects traffic, layer 4, layer 7. It can provide outbound source network address translation, but it's not very efficient. I think it only gives me 2,496 ports per IP per backend instance. I can have lots of IP addresses, but it's just not as IP efficient as other solutions. Again, it's fantastic inspection, layer 4, layer 7, including TLS. It can crack open the packets and look at them, but it's not that efficient with the IP addresses. I could use a third-party network virtual appliance that has a public IP. There are many options available to it. But really just be careful with this. Whenever I start thinking about external access from the internet, be careful what you're exposing. I don't want everything just available on the internet, which really comes to, this warning right here. If I have a resource, I should not have RDP or SSH or WS-MAN. Like, those things should not be available from the internet. If you do enable those things from the internet, you can just sit and watch as everyone's trying to hack it. It's not a good thing. If I must RDP to my resource in Azure from the internet, use something like Defender just in time. And what that will do is it will use network security groups, i.e. controls, to only allow access from your current IP address for a limited window of time. There are solutions like Azure Bastion, which provides a managed jump box experience that uses entry authentication to go and leverage those things. But really, ideally, what we're going to do, and we'll see this virtual network with my stuff in it, well, I'm going to want it connected to my on-prem network. I want these resources to really just have an IP path on private networking directly, so I don't have to go via the internet to talk to my stuff. I want to think about these virtual networks being an extension of my existing network. That's really the goal of what we want to get to. Now, one thing, when I talk about public IP addresses, we saw we create that public IP resource. It's its own resource. And depending on the region, I'll get a public IP address from Microsoft-owned sets of internet routable addresses. So Microsoft owns those public IPs. Now, there are occasions where maybe I don't want to use Microsoft's address ranges, in which case you can bring your own. Imagine, for example, I currently have a service that I host on premises and I'm exposing it through an IP address I own. And maybe that IP address has got a certain amount of reputation. It's known by the parties that talk to it. They have firewalls that enable communication from that IP address. And then I'm migrating that service to Azure. Well, I don't want to lose that trust maybe from that IP address or those range of IP addresses. So I want to bring it to Azure, that public routable space. Now remember, internet routing is complex. I can't just bring an IP address and expect it to route from the internet. And the internet is really just a whole set of networks that understand and learn the paths and the connectivity between all of those networks. So what Microsoft have enabled is the ability for me to bring a portion of IP space that is internet routable into Azure. And so what I would do is I would bring a specific portion of my IP space, and I can bring both IPv4 and IPv6. And what will happen is it will get created as an Azure address prefix. A prefix is a contiguous set of IP addresses. And what I can do here is for IPv4, the global range, so the set I bring to Azure, has to be between a /21 and a /24, or it has to be a /48 for IPv6. And I then break that into regional child ranges that I would then use for regional services that live in a region. Those regional child ranges for IPv4 would be /22 to /26, or a /64 for IPv6. Now, because public IP ranges are governed, they're allocated by global internet bodies, and they're part of that much larger routing system. There's multiple steps to bring that IP space to Azure and then have Microsoft advertise out to the internet and update all of those routing tables throughout the world. Hey, if you want to get to this IP address, you now need to come via my public points of presence to get to my network. So what it is we have to validate. So firstly, you have to be able to prove that you own this portion of the address space. So you are registered with some routing internet registry, ARIN, RIPE, and you own it. And so you have to authorize Microsoft to advertise the range. You'll then provision it. So the range will be created as a custom IP prefix in your subscription. And then once you've done that, public IP prefixes, public IPs can be derived from that range and associated with Azure resources. And it's going to support those standard SKU public IPs, but they're still not advertised. They're still not reachable. I then have to commission them. So you issue the command, and then that range will be advertised by Azure, first at the regional, and then to Microsoft WAN, out to the internet. So there's significant steps required to do this, but the upshot is I could now bring my own IPs into Azure. Now, again, generally people don't talk directly to IPs. I want to be using DNS names, so I have some flexibility there. We generally don't trust just the IP address. We want to use authentication and multiple layers. But if I do have some kind of service that has established a trust that is configured for things to talk to, this would enable that capability. Next, I want to talk about connecting virtual networks. Because remember, your virtual network is bound within a subscription, within a region. And so if there's any scenario where I have more than one region or more than one subscription, I'm going to have more than one virtual network. I'm going to have multiple virtual networks. Now, in ye old days, one of the ways, or the way, is I could connect virtual networks together by connecting them to the same exchange route circuit. Or I could connect them via a site-to-site VPN. Both of those are really kind of terrible solutions. So let's look at the ExpressRoute option. So in the ExpressRoute, I buy a circuit. Now, I'm not going to go into all of the details of how this works, but at a super high level, think about you have the Microsoft backbone network. And then what happens is at certain points on that network, Microsoft expands its network into carrier-neutral facilities. A point of presence where different networks come together, for example. And then also, what you have here is obviously all the Azure resources. So imagine I had VNet 1 and I had VNet 2. And I want them to be able to talk to each other. Now imagine they're in the same region, they're right close, they can almost see each other. It's software, but they're right next to each other, super low latency when they would talk because they're in the same region, same sets of data centers. And let's say I connect them via the same ExpressRoute circuit. I connect them to the same circuit. So they've both got ExpressRoute gateways, and I connect them to the same gateway. This meet me, let's say this is South Central US, and let's say this meet me is in Dallas. The flow of traffic is going to be via the meet me. So even though these are in the same data center, when they talk, they're going to flow via something hundreds of miles away. So latency is going to suck. Like I'm adding in a whole bunch of latency for no real good reason. The other thing I could do is use a site-to-site VPN. Remember, site-to-site VPN is encrypted. So now what would happen is, okay, I could do a gateway. I've got a gateway in each of them. And I establish a site-to-site VPN over the internet. But Azure would be smart enough, it won't bounce the traffic via the internet, but it doesn't have to encrypt the traffic. So I'm going to be restricted to the bandwidth of the gateways because it's having to do with this encryption, so it uses a whole bunch of compute. So the long and short of this, both of these are not very good. This adds a bunch of latency. This also adds a throttling of the bandwidth because of the encryption. So I don't really want to do this. This is not the solution that I want to be able to leverage as part of my environment. And so the better option is something called virtual network peering. This enables the networks to be connected in that software-defined networking just using the Azure backbone. I'll get the regular performance of whatever the resource is capable of. There is no new limits introduced. I can connect virtual networks in the same region, regional peering, or in different regions, global peering. The virtual networks can be in different subscriptions. They can even be in different tenants. Now, if the virtual networks are in the same subscription, when I go and create the peering, it can create both ends of the peering. There's a certain sequence of actions. I need a permission to request to create a peer to another virtual network. And then I have to acknowledge and I create a peer in the other direction. But if they're in the same subscription, I can create both ends of the peering in one action. If not, it'd be a multi-step sequence. And so what would now happen, if I think about this, so this is VNet 1. What I can now do is I've got another virtual network. So this is VNet 2. Now remember, VNet 2 has its own set of IP addresses. It's defined by a different IP range. They cannot overlap. Because remember, I want to be able to route traffic between these. So the IP ranges cannot overlap these things. And then I just establish a peering relationship between them. So now they know about each other. And again, there could be multiple subnets that make up this virtual network. And now I've got IP address flow between them. Now, one thing to bear in mind, this is fantastic. It's quite simple to set up. I now get full IP traffic flowing between them, but I do pay for that traffic. So there are both ingress and egress charges as part of virtual network peering. So when I look at the pricing of virtual networks, just be aware, I do pay. So within the same region, it's basically a penny, a cent per gigabyte in each direction. If it's global, then it's going to depend on what zone. There's different zones that make up the different regions, what I would then pay. So I am paying more money when I do that global peering. So just be aware this is not free. There are definitely charges associated as part of using that virtual network peering. As mentioned, I'm establishing routing. So they can't be the same IP space because how would they be able to route? Now, one of the things you could do is the grandkids, if that makes sense. So imagine I was peered to another virtual network as well. So let's just say, for example, I've got another VNet here. This is VNet 3. And that's a different IP range, SIDA 4. And these were peered. So these have to have unique IP ranges. SIDA 3, SIDA 4, SIDA 1, they cannot overlap. But technically what could happen here is this could then peer to another virtual network that is maybe SIDA 5. And this peered to another virtual network that used the same. This is CIDR 5 as well. Because these routes are not propagating. So this is talking to this IP space. These all have to be unique because they're routable. But this is not passing on this IP space to this network, which means those can overlap because they are not talking to each other and learning these different routes. So as long as they're not propagating routes, technically, so think of these maybe like some sort of hub networks. These could talk to maybe regional VNets that are using the same 10.0/16 space, for example, because I've got my app VNets here that don't have to go and talk to each other. So there are ways then, sure, those child of the peers could overlap because this VNet here is never learning these IP spaces. It never talks to them because these are not transitive connections. So I just wanted to quickly go over that as a capability. Now I'm going to erase that. So that's the one time they could overlap because we're not learning those different things. Okay. So speaking of which, peers are not transitive, but they can be. As mentioned, I don't just learn those things. Now, if we look at this picture again, one of the capabilities we have is, let's take out this peering for a second. Imagine, for example, instead the peering is this way. With this relationship, can this VNet talk to this VNet? It can't, because they are not transitive. These connections are not providing communication. I would have to manually add this peer if I wanted this VNet to be able to talk to this VNet. So they are not transitive. I guess one thing I should actually mention when we talked about those overlapping IP ranges and problems, one of the things Microsoft has added is the ability to do subnet level peering, which is kind of a cool thing. So I drew this peer here that you're peering the entire IP space of the virtual network. Technically, another option you can do now is there's a new parameter, peer complete VNet. If I set that to false, I then specify the specific local and remote subnet names I want to peer. So what I could actually say is, well, no, I just want to peer these subnets to these subnets. So I can be more specific if I want to. So that's an option now. And when I do this, I could also just peer the IPv6 space. I could say, is IPv6 only peering, and only do that. So that's a capability I can now do if I wanted to just peer portions, because maybe they do overlap. There's some problem. So I could peer non-overlapping subnets. There's some weird things that I could now do. We'll talk about this later on. If I ever get to the stage where I have overlapping VNets and I need them to be able to talk, I need to do something called network address translation. So remember the term private link. That's your solution when you have overlapping IP spaces. But back to our problem, these are normally not transitive. I would have to go and add the peering. One of the things you can do, though, is if I want them, is I don't want this huge mesh network. I've got the idea of, let me redraw this picture. So imagine I had the scenario where, okay, maybe I've got a hub virtual network. So this is just my hub. And now imagine I've got a whole bunch of spoke. So this is the middle of the wheel and I've got these spokes. So I've got these different spoke virtual networks. Now, ordinarily, they may not need to speak to each other. So it's not a big deal. And so they would peer to the hub. So they can talk to my hub network, but they cannot talk to each other. If I wanted them to talk to each other, well, that's when I would have to go and create peering. So I'd have to create this huge mesh. So that would be a huge amount of different peering connections. And we could see that. So if I actually jump over for a second, if we look at my virtual networks, I've got a hub virtual network right here. And if I look at my peerings, it's got peerings to 2 spokes, hub spoke 1 and hub spoke 2. But those 2 spokes cannot talk to each other. They can only talk to the hub because the hub is providing the services. They're the things they actually want to be able to go and talk to. So it's all well and good. But imagine I want them to be able to talk to each other, but I don't want to do this. Maybe I've got hundreds of spokes. I do not want to have to create that full mesh network. That would be a huge amount of work. So one of the things I can do is I can go ahead and I can add Azure Firewall, or it could be a third-party network virtual appliance. And what I'm going to do is this is going to get added as a resource. So let's pretend this is Azure Firewall. Now that Azure Firewall has an IP address from this IP range. So let's say it's IP1. One of the things I can do here is I can tell spoke 1, if you want to speak to spoke 2, talk to IP1, because IP1 will forward the traffic for us. And the way we do that is we create something called a user-defined route. So I'm going to create a user-defined route. And as part of that, I'm going to say, look, if I want to talk to this IP range, CIDR 2, you need to go and talk to IP1. And because this is all software-defined networking, this is about next hop. It doesn't have to be in the same subnet or even virtual network. So my next hop can still be an IP address in a different VNet. So hey, someone in here wants to talk to someone in here. It will just send the traffic to the Azure Firewall that can then forward it on because this has connections to both. For this VNet, I'll create a user-defined route that says if I want to talk to CIDR 1, then my next hop is IP1. So it would say, oh, hey, send it to this, and it would forward it on for me. And then what I would go and do is link this to the subnets within the virtual network that need that connectivity. So user-defined routes are really powerful for this capability. If you have the Azure Virtual WAN, which we'll talk about, does this for us. But at a super high level, if I just look for, is it route tables? It's UDR. If I look at my route table, what I define are routes. When I add a route, it's a name. What is the destination type? So it's an IP address, or it could be a service tag, which is a set of IP addresses for certain Azure services, say IP addresses. I would put in that CIDR 2 for the spoke. And the next hop, if it was Azure Firewall, would be a virtual appliance. And I would put in the IP address of the Azure Firewall. But you can see the next hops could be a virtual network gateway, virtual network internet. There's a whole set of default routes that are plumbed into virtual networks. There are other routes that get learned by gateways, and then there are particular routes I'm adding as part of user-defined routes. So there's a whole sequence of different routes available that I can do, but this would plumb in those user-defined routes that would enable that connectivity via the firewall. Now, while I'm over here, if I look at my virtual network again, and look at my peerings, you'd see there's some options. And there's things like, hey, allow gateway or route server in VNet hub to forward traffic to, enable to use a remote gateway or route server, allow forwarded traffic. There's all these different options. So what are these different things all about? And it comes back to the idea that, well, if I think about my hub, what does your hub probably have? Yes, you might have some resources that these want to use, but most likely also what that hub has is connectivity. So it's going to have a series of gateways. So from those gateways, it might be talking to ExpressRoute. So it may have an ExpressRoute gateway, so it's connected to an ExpressRoute circuit. That circuit then gives me connectivity to maybe on-premises locations, for example, using something called private peering, which we're going to talk about. And or maybe it's got just a site-to-site VPN, and that site-to-site VPN is connected to our on-premises networks. It's just going over the internet. So it has connectivity to stuff. So that gateway will connect to other IP spaces that it will learn about, and then through BGP, Borderless Gateway Protocol, which is really a way to learn routes and plumb them, it will plumb them into this virtual network. So things in this virtual network say, hey, if I want to go and talk to this IP space, which it now knows about because the gateway plumbed it into the routing table of the virtual network, I'll send it to the gateway, who will forward it on for me. So all of those other settings we just saw basically enable me to say, hey, look, I'm the hub on my peering that way. I'm going to allow gateway transit. I'm going to let you use my gateways. And on the peers, I would say use remote gateway on my peering connection that way. The net result of that is that now this hub in this peering connection would propagate the routes that it's learned through the gateway into these VNets as well. And so now something in this VNet says, oh, I want to talk to this IP space. I know I need to go and send it to this gateway. And also now things on these networks could now go and talk to things in these spokes. So it's a way to expose and extend that routing. Now you also saw it use the word route server. So route server is another component of the Azure networking stack. Then imagine I'm not using Azure's ExpressRoute gateway or site-to-site VPN gateway, because those components automatically plumb the IP spaces they learn into the virtual network's route tables. So I don't need to do anything else. But imagine I'm not using those gateways. Imagine I have a network virtual appliance. Maybe it's talking to an SD-WAN. So it's its own component. But again, that goes and talks to other IP spaces. Well, it can't go and plumb those routes directly into the virtual network. So I'd have to go and create these user-defined routes that says, hey, if I want to go and talk to the IP space that this third-party network virtual appliance, this SD-WAN solution talks to, we'll go and talk to the IP address of the network virtual appliance. So I'd have to maintain those routes, update the IP spaces if the IP address spaces it's talking to changes. It's a lot of work and it's messy. So what Azure Route Server does is it becomes a conduit to plumb routes into the virtual network. So I would deploy a route server, and then the network virtual appliances establish BGP sessions with the route server. They tell the route server, oh, these are the IP spaces I'm talking to. Route server then plumbs the routes into the route table of the virtual network. So it's establishing these BGP sessions that now let things learn those IP routes so we can go and talk to it. And so the point is these settings also would work with route server and the IP spaces it's learned about from the NVAs it is talking to. Note that when I use route server, the traffic is not flowing through route server. The route server is really just there as a BGP session establishment to plumb the routes into the virtual network. So it's just a really nice capability. If I do this, the spokes can't have their own gateways. I can't have like my own ExpressRoute gateway over here or site-to-site VPN gateway and use remote gateways. So I would be concentrating the connectivity into here. So that is a super, super common configuration that, hey, we have the hub, I focus on the connectivity in there, and then I want to enable the spokes to do that. And then maybe I also want them to be able to talk to each other through something like the Azure Firewall. So cool stuff. So connecting to on-premises, we already alluded to this. So firstly, very few companies are just everything is in Azure. Very commonly, you're going to be in a hybrid scenario, so you'll still have some services on premises. You might have clients on premises that want to consume the stuff in Azure, vice versa. And so, yes, the Azure services, for the most part, like many of the PaaS service, the platform as a service, they have internet-facing public endpoints. So I could consume them that way, but very often I don't want to. If I'm on my internal corporate network, I don't want to bounce via the internet to go and talk to a Postgres database I'm running in Azure. I don't want that. I want to think about that Azure Virtual Network as an extension of my on-premises network. So generally what we want to be able to do is make the Azure Virtual Network and any services connected into that virtual network. Again, trying to think private endpoints and private link. When I talk about it later, it'll make more sense. But anything I plumb into that virtual network, I want to be able to be accessible to my on-premises network. That's a very attractive thing. And so there are a few options for virtual network connectivity. I can do a point-to-site VPN. So when I think about a point-to-site VPN, it's a specific client, like my laptop, that I've taken to a coffee shop that is talking to my Azure Virtual Network. But it's just establishing the machine is talking to that network. Then the other things I can do is we have a site-to-site VPN that's connecting a network to another network. It's connecting maybe my on-premises network to my Azure Virtual Network. And actually, let's start drawing these out. We'll go over here. We have lots and lots of pictures. So let's go back a step. So imagine I've got my region. So this is a particular region. And in my particular region, remember I've created my particular virtual network. So I've got my VNet. Now, when you talk about Azure regions, one of the important things to realize is there's this massive Microsoft wide area network. So there's this global spanning, one of the biggest networks in the world, the Microsoft backbone. So the Microsoft wide area network. All of the Azure regions connect into that. So you can think about at the edge of the regions, this is not in my VNet, this is the physical infrastructure of Azure. There are these things called regional network gateways. And these are highly redundant, but they connect into that Microsoft backbone network. Now that Microsoft backbone network also connects around the world to many points of presence. Now there's different types of these. There are ones for private connectivity, but there are things like these various points of presence where it just goes and connects to the internet. So that's where it can get connectivity. So when I'm talking to an Azure service via the internet, it's coming in via these points of presence it has all around the world. So there's ones close to me, so I get the lowest possible latencies to hop onto the Microsoft network to then go and talk to things within the region, within my virtual network. But when I think about, okay, I've got my virtual network and I want to start talking to other things. The first thing, I'm going to take up most of the VNet, but this wouldn't normally be the case. Actually, different color. One of the first things I need to do is I have to create a gateway subnet. So I'm going to create a subnet specifically for the purpose of housing the various types of gateways. Now, this gateway subnet, to give myself breathing room, I normally want to create it a /27 or above. It technically can be smaller. It can be as small as I think a /29, but then it limits my ability to maybe grow, maybe site-to-site VPN and ExpressRoute. So we're going to want it to be a /27. And let's think about VPN initially. So what I have to deploy, and I'll get a pair of these, are these VPN gateways. Think of these as managed virtual machines that Azure creates for me. And those are now exposing the ability to create a VPN. Now, there is route-based and there's policy-based. Route-based is the preferred, it's the default. It's going to depend on what is my on-premises infrastructure to exactly what you can use, if you think of it that way. But nearly everything is going to support route-based today. That's going to dynamically enable the IP address. Is policy-based is static. It's really deprecated today. But what we're going to now have is I've got my on-premises network. And what I'm going to want to do is I'll establish connections to the VPN service in Azure. Now, there are different combinations in how I can actually use this. So if I think the Azure side and my side, so those VPN gateways can either be active-active or active-passive. We have different configurations in there. If I think initially it's active-passive, and then realize you've got your side. So your side, well, maybe it's just active, and maybe you don't even have another one. So initially, you would just have one connection. That's kind of sad. It's not super resilient. If there was an outage, this failed, this would then become active. It would have to establish the connection. There would be some downtime. And so the better option is to make this active-active. And now it would establish dual connections. So I've got resiliency from a failure in either one of these. But even better would be you have an active-active set of gateways on your side. So now what we do is you get this bow tie pattern. You always like the word bow tie. When we think about resilience, it means there are these cross connections going both ways. So now I've got resiliency from any of these failing as part of my VPN configuration. Active-active is available for all of the gateway SKUs except basic. I can change an existing active standby to active-active very easily. If I was using, again, active standby, I would see a brief interruption as part of an outage or even planned maintenance. So if I am using the VPN gateway, remember it's going over the internet. And so latency could vary because I'm going over the internet, going via different routers. I don't 100% know the exact path things are taking all of the time. But I can still have a very resilient, it is encrypted. So, hey, a pretty good option there, typically for smaller organizations, because the bigger organizations, those are the different types, are going to use ExpressRoute, specifically private peering. So private peering is connecting IP spaces together. So that's connecting a network to a virtual network via a peering location and a gateway. And so now if I'm using ExpressRoute, what's happening is it's a different color. Now I've got ExpressRoute gateways. But now what's happening, these points of presence we talked about before. Again, there are many of these all over the world. So now that Microsoft backbone is extending into these carrier neutral facilities, got these resilient connections. And I can think about one of these locations. So you might hear this called a peering point. You might hear it called a meet me, because we're meeting networks here. Whatever that is, within this peering point, Microsoft has something called the Microsoft Enterprise Edge. It's their routers. So they will have a pair of routers. They've got many, many pairs of routers. But the point is for your particular ExpressRoute circuit you buy, what happens here is your ExpressRoute gateways they go and talk to the Microsoft Enterprise Edge. And it actually does a bow tie thing here. So both of them are actually connected to both of those Microsoft Enterprise Edge routers. So those are in Microsoft-owned cages at that carrier-neutral facility. Then what happens is you've got your location. Now, most likely you're using a service provider to do this. Could be an AT&T, an Equity, whoever that is. So you've got your network and you've got your own sets of equipment and connections. Now, maybe you have got a direct connection into this point. Maybe you've got an MPLS, which this is going to be part of. But you basically have your own routers on this side that these are going and talking to. And that's establishing now your ExpressRoute connections. So it is always two connections. They're running active-active. And that's being used for data path and for BGP to exchanging those routes. So it's very resilient. Now, what this does mean, because both of these connections are active, you buy a circuit of a certain size, let's say 100 megabits per second, what you'll actually get on a sunny day, i.e. there's not a problem, you'll get 200 megabits per second because they're both running. But if there was maintenance, if there was a problem, you would drop down to whatever that regular thing you've paid for is. Now, when I think about what I'm paying for is the circuit. So I'm paying Microsoft for the circuit. I'm paying the provider for their part of it. I'm paying for the gateways. And then I'll also pay for the egress. I don't ever pay for ingress into Azure. There's a few when I'm doing like peering and private endpoints. But I don't normally pay for data ingress. I pay for data egress. Now, if we look back over, we can look at a number of these different things. So firstly, the locations of where I can use this. So what we'll see here, actually just keep scrolling down. So it shows me, based on the physical location, what is the actual different service providers that are offering ExpressRoute services, what is the actual address, like that physical meet me location. And you'll notice there's a local region. Don't worry too much about that right now. Sometimes there isn't. But normally there's this local region. We'll come back to that. But you can see there's different providers providing ExpressRoute at the different locations all around the world based on exactly where you are. So there's a Dallas one. There is no local region because there is no Azure region in Dallas. Obviously, you go to San Antonio or something. Then it's South Central US is the local region. So there's different capabilities there. And then also you have different gateway SKUs. So different gateway SKUs have different resiliency. So often these days you'll want to look at ones that have the AZ. So the gateways themselves, those active-active, they're spread over the two different AZs. But you'll see, hey, does it support something called FastPath, which we're going to talk about? The maximum number of circuit connections. So a single gateway can actually connect to multiple different circuits. You'll also notice this thing called ExpressRoute Gateway Scale. So I get a configurable number of units to see how much sort of throughput I actually need. So there's different gateways, different capabilities. But the important thing here is only the Ultra and the Gateway 3AZ supports this FastPath thing we're talking about. But all of them can support coexistence with the VPN gateway. So I could have the option of having VPN and ExpressRoute. So we have those various different capabilities available to us. Now again, with those different types of circuits, there's metered, where I would pay for the data egress, or there are non-metered ones. Now the non-metered ones, I pay more money for those circuits, but I don't pay for the egress. If I was doing some massive amount of egress through the ExpressRoute, it might be worth doing the non-metered. Most of the time, you're better off just paying for the egress. Now, as mentioned, I buy a circuit, and a circuit is connecting to a certain location. Multiple different gateways, i.e. VNets, can talk to the same circuit. So as we talked about before, I could have another VNet over here with ExpressRoute gateways connecting to exactly the same circuit. And then yes, technically those things could talk to each other, but it's going to hairpin via this, so I'd be adding latency all the time. It's normally 10 different VNets can talk to the same circuit if it's a local or standard. If it's premium, then the number of VNets is between 20 and 100, depending on how big that circuit actually is. There's also something called premium. Premium adds the ability to have up to 10,000 routes learned from on-premise instead of 4,000. It can also talk to regions across the globe instead of just within the same geopolitical boundary. It can also connect to M365 is another capability, whereas regular ExpressRoute can only talk to regions within the same geopolitical boundary. And we're going to talk a little bit more about this in a second. Additionally, so a single gateway can talk to more than one circuit. So one of the things we really like to talk about from a resiliency function. So realize this is a physical building, right? So yes, there's a pair of routers, but they're in the same building. So if the building had a failure, and this famously happened last year in Chicago, it froze. And so yes, I've got two routers, but they're in the same building. So the building has an issue, my circuit's down. So what we really want to have is when you're designing this, you should have another circuit. So what I want is another circuit in a completely different physical city, like hundreds of miles apart. So what I would then do is my ExpressRoute gateways would also connect here. And that circuit would also connect to your MPLS or your network as well. And so the benefit here, because you're adding like a big gap, big distance between them, I've now got resiliency from that physical location having a problem. Then a number of different circuits a gateway can connect to is between 4 and 16. Again, it depends on those various factors. The scalable gateway, again, depends on the number of units you've got. But this gives you that higher level of resiliency from any kind of meet me facility failure. There's actually another option. So there's something called ExpressRoute Metro. So we talked before about you have this pair of routers, and that pair of routers is in the same physical facility. So what ExpressRoute Metro does, so imagine there's another physical facility, but it's in the same city, it's in the same metroplex. So it's within the same city, but now what it does is the pair, the other one in that pair, moves to the different physical facility. So now that circuit has resiliency from a building level failure. Again, if the whole city floods or something, you have an issue. But now the nice thing is I have resiliency from a facility level. Think of it almost like using availability zones in Azure. This is a little bit like having availability zones at the meet me for your connectivity. So this is the ExpressRoute Metro option. And it's good to use that if you have the option. Now that's in early days at time of recording, but that is something that is there. Normally we buy a circuit. For very, very large companies, you can buy something called ExpressRoute Direct. With ExpressRoute Direct, I just buy the ports. Now, ordinarily, I don't own this whole router. I don't even own the whole port. It's shared across different customers. With ExpressRoute Direct, I buy the pair of ports. So it could be 10 gigabits per second or 100 gigabits per second pair of ports. And then what I do is I create circuits on top of the ports of different sizes based on what I want. But I'm owning the port because I'm really big. I'm used to dealing with fiber lines, and I get letters of approval, which means I'm allowed to go and hook up my router into the particular port at the Microsoft Enterprise Edge. But if I want that, there is that option to actually go and buy the entire port. Now, another thing we have is something called the local SKU. Now, we talked before about paying for egress and paying for these different things. I talked about premium and standard and different access. So we have this kind of 3 levels. So there's something called local. With local, remember that meet me, when we looked at the chart, some of them had the idea of a local region. We saw that available. So in that case, this was the local region. One of the things I get here is free egress. But I can only connect to the region that is that local one. So if we jump back over again and we look at that chart, remember where it says the local region? So if I went and created a circuit here, the only region that could have gateways connecting to this circuit is in South Central US. But the nice thing then is I would not pay for egress. So if I needed like high throughput, but I only need it from a particular region, or I set up a series of circuits in different meet-me's with different Azure regions, that might be an attractive option to do. Okay. Then the other one I can do, obviously, is the standard. So with standard, in addition to using, hey, that local region that's paired, well, I can use any of them in the same geopolitical boundary. So America, for example. So I can use that region. I can use this one here and this one here. They have to be in the same geopolitical boundary. And then my other option is I can do premium. Premium, as you kind of guess, is global. I could create a circuit in Dallas, and I could connect it to Azure resources that are in Europe. So if it's in the same cloud, like commercial cloud, then I can do that. The other thing this lets me do is something called Microsoft 365 connectivity. So there's saying, we talked about private peering, which is connecting the IP spaces. There's also Microsoft peering. Microsoft peering lets you create route filters to say, hey, actually, these Azure services, let them advertise to your on-prem network as well. So maybe I could go and connect to storage or these databases via my ExpressRoute connection as well. But in standard, I can't connect to M365 services. With premium, it does let you do that. Generally, you never want to do this though. M365 is designed to be talked to from the internet. As soon as you try and start plumbing it into ExpressRoute, you have to be really careful because you end up with traffic flowing different paths, and then it breaks your firewalls because it's getting a response coming from one route that is not expecting because it's sent it out on another path, and it just breaks. Like most companies that try this end up breaking it. So it's generally not something I actually want to do, but technically I could, with premium, have M365 advertised over my ExpressRoute as well. Also, if I had a massive number of on-prem routes, this supports up to 10,000 routes instead of the 4,000 of standard. So that's one of the benefits there. As mentioned, I can coexist ExpressRoute gateways with VPN gateways. So the ExpressRoute would be the preferred. The site-to-site VPN would be the backup. I can also actually do site-to-site VPNs over the ExpressRoute. Maybe I want to encrypt the traffic. So that is an option if I want to do that. I already talked about the ability that, hey, when I have these ExpressRoute or site-to-site VPN gateways, when I do, for example, the peering, I could use from the spokes that connectivity because it's going to do the route propagation when I allow that gateway transit and then say use the remote gateways. The only other thing I'll touch on super fast is we do this idea that I have one location. What if I have 2 or 3 or 4? So imagine I have another location over here. And this location over here actually has its own ExpressRoute circuit. So, hey, there's another ExpressRoute circuit over here, blah, blah, blah. It has a connection to it. Now, ordinarily, I as a company will have my own backbone network. I'm paying a provider to provide me private connectivity. But when I have these multiple ExpressRoute circuits, so I've got another ExpressRoute circuit 2, one of the capabilities you can enable is something called ExpressRoute GlobalReach. So when I turn on GlobalReach and configure it for the circuits, what it will now allow is this location will go up to the MeetMe onto the Microsoft Backbone Network, over the Backbone Network, down to the other MeetMe, down to the location, and they can talk to each other. So those different locations will now establish connectivity via the Microsoft Backbone Network. So you can always go and look at that. That is another configuration option. When I have multiple circuits, when I have multiple locations of my own, I can actually go and configure that as a capability where I need that as an option. So it might be a backup. It might not be your preferred approach, but maybe if I had some kind of failure on my regular network, then I could fail over to using the ExpressRoute GlobalReach to keep my various services running. So let's talk about ExpressRoute FastPath. Really because when we looked at the private peering, remember we had the gateways. Now those gateways run within the virtual network. They have a number of functions. They do BGP. Remember, BGP is about learning and exchanging routes and then plumbing them into the virtual network. So that's critical because we have to know the IP spaces for the on-premises network so that then the resources know, oh, if I want to talk to an IP address in here, we'll have to go and send the traffic to this gateway that will go and send it on to me. So that's a critical function of that. But also, it's part of the data path. So when I think about that flow of data, what's actually happening to send data into a resource within the virtual network, what actually happens is the data path is, well, it has to have somewhere to send it to that's a valid route. So the path is it sends the data to that Microsoft Enterprise Edge, which then sends it to the gateway, which then sends it through. And so what's happening here is because the Microsoft Enterprise Edge has to have a valid destination, the gateway is part of the data path to send data into the virtual network. Now, it is not part of the path for data to go on premises. The data actually will just flow directly to the Microsoft Enterprise Edge to the network. So the gateway is not used for data egress to your virtual network. But it is in the data path for the incoming traffic, which means obviously it's introducing a certain lag, a latency to that data flow. And so one of the things we can do is ExpressRoute FastPath removes the gateway as part of that data path. And so now I can actually get a higher throughput because it's not getting used as part of that flow at all. Now, we still need the gateways. You can't just get rid of the gateways. Remember, it had two functions, BGP. So I still need the gateways for the BGP sessions to exchange those routes. But now that's all it's doing. Now I do need the Ultra Performance or the ExpressRoute Gateway 3 AZ, the zone redundant version, to turn on FastPath. Because realize what it's now having to do is basically the information that's needed to send the data has to bring it into the Microsoft Enterprise Edge, removing the need to talk to the gateway. If ever there's a problem with FastPath, it will fail back to using the gateway for the data path until it can reestablish the regular bypass. Now, there are limitations this introduces. Basically, check the documentation. So if you go and look at the documentation, it explains the way it's bypassing, but you want to read the limitations. Certain challenges with the load balancers, some of the gateway transit. There are some different things about using ExpressRoute Direct. There's some of the things it now supports for using private link if I'm using 100 gigabit per second ExpressRoute Direct. But there's just a few nuances to be aware of as part of using FastPath. So overall, it's great because, hey, I'm now not going via the gateway, so I'm not going to get limited to the throughput of the gateway. It's going to reduce some of that latency, the lag it was introduced, but there are a few limitations to it. So moving on, what about controlling traffic flows? Remember, within a virtual network, traffic can flow freely. If I have internet egress available, it can talk to the internet and receive the response, but it can't just receive from the internet. I can talk to any peered virtual networks. I can talk to connected networks. But maybe I want to control the traffic. And so I can think about segmenting, so these resources can talk to each other, these can talk to each other, these can only talk on a certain port, only this port is allowed from the internet to these set of resources. And there's a number of different approaches I can use. So one, I can use Azure Firewall. So Azure Firewall is great for doing deep packet inspection. It can do layer 4, i.e. the network. It can do layer 7, i.e. the application, which can then look at the fully qualified domain name. It can do TLS inspections. We can crack open the packet. So then I could look at the full URL in the path as well. So maybe do categorization. It can do some destination natting for some end target based on port. It's a very rich, powerful solution for when I want to do those types of inspections. So if we looked at our picture for a second, where did I draw Azure Firewall? So look, I know I drew one somewhere. Somewhere on this picture is an Azure Firewall. There we go. All right. So this Azure Firewall, one of the great things this lets me do is I can define rules. So the traffic flows through here. I can do layer 4. So remember, layer 4 is just a network. I understand things like the port, the protocol, but I don't really have an understanding of the fully qualified domain names or paths. Layer 7 is the application. So I can define rules at both of these different layers to do the various inspections. And one of the nice things at layer 7 is I can do TLS inspection. I can have different categories that when I do the TLS inspection, I can also use the path. There's intrusion detection prevention systems. There's a whole set of different capabilities. Now, it does vary depending on the SKU. So if we look at the 2 SKUs that are available, actually, is it 2 or is it 3? 3 SKUs that are available. We can see there's the standard, there's the premium, and there's the basic. And you get different capabilities depending on which one you do. So we see premium, well, that's adding. Because of the TLS inspection, I can now use the full URL as part of the filtering. I can use the full URL as part of the web categories. And also now I have an intrusion detection prevention system. Basic is really designed for lower throughput. It's got a better price point. It's got some capabilities, but obviously it's just not as full function. The threat intel is alerting, but it won't stop the traffic. There's a comparison. So here I can actually drill down and see the specific detail of the capabilities. So I can help decide the exact ones I want. So different SKUs, different amounts of scale it can handle based on the particular one I want. So here, obviously, if I was using this capability, then what I have to be doing is making sure the traffic is flowing through it. So I would be using these UDRs to say, hey, send the traffic through my Azure Firewall. I could do the 0.0.0/0, everything to go and send through it. But obviously, the appliance is having to process that traffic. Now, Azure Firewall runs in Azure Firewall subnet /26 you dedicate to it. It's fully managed. It's built on VMSS and it will auto scale as it needs to. Super powerful rules, but maybe I don't need those. Maybe I don't need all of that capability. And so the other thing I can do is network security groups. And there's also application security groups. There's service tags, which we're going to talk about. But fundamentally, network security groups I can apply it at a subnet level or an individual NIC, whichever you want to use the subnet. It's just easier to manage. As soon as we start trying to apply these at a NIC level, it gets super, super complicated. But the enforcement is always done at the virtual switch. So it's always enforced at the NIC level. So don't think, oh, I'm going to apply it at the NIC, that's better. It doesn't work that way. Even if I apply it at the subnet, it's enforced at the NIC level. It's not an edge device. So what that would mean is it's still going to go and inspect the traffic even within the same subnet. Now, the NSG, when I create this, must be in the same region and subscription as the VNet where I want to be able to use it. Now, there are default rules, and the rules are really made up of IP ranges, tags, ports, and actions. If we go and look, so let's go and look at NSG. So network security groups. And we'll just look at, demo one. So we've got inbound rules and outbound rules. Now, these three you see here, firstly, have a super low priority. The higher the number, the lower the priorities. This is basically as low as they come. And you can see these are the defaults. If I hide the defaults, they disappear. So I'm clicking this button right here. And what these rules are doing, well, you can see allow VNet inbound. So what it's saying is traffic from the virtual network to the virtual network is allowed. Traffic from the Azure load balancer to anything is allowed. Everything else, I'm going to deny. So things in the VNet can talk to each other, and the load balancer can talk to the stuff. Outbound, again, anything in the VNet can talk to each other. Anything can talk to the internet outbound. Remember, it's stateful, so we can get the response back. Everything else is blocked. Notice for the inbound, there is no from the internet. So by default, nothing from the internet can talk to it. Now, one really important thing here is when it says the word virtual network, this is a special tag. And what a virtual network actually means is the known IP space. So if I was to look at this picture, for example, and you saw the word virtual network, you would think virtual network, it's something with a service tag, would mean this IP space. It does not. Virtual network is this IP space and every known IP space. So it would include all of the VNets it's peered to. It would include the IP space of anything that it is connected to via ExpressRoute, private peering, or site-to-site VPN. So think of it as the known IP space. That's what virtual network means. It's all known IP ranges. Internet is all IP ranges that are not part of the virtual network that are reachable by the internet. Now, we actually see those special tag things I'm talking about, they are outlined. So we can go and look at these. So we'll see there are a number of service tags. And you can see there's various Azure services. You can, if we scroll down, we'll see the idea of internet. And I can use it both inbound and outbound. And we'll also see the word virtual network. All of the known connected IP spaces. Now, you might be wondering, what are the point of these service tag things? So I'm going to create some rules. And maybe I want to create a rule and the source. Now, I could do my IP, a set of IP ranges. But what if I want to enable it from Azure storage? Well, really more likely, I want to send it to Azure storage. So I was going to create an outbound rule, and I want to be able to talk to Azure storage. Well, if you think about the way the services work, Azure storage can have a public endpoint, but it's a massive range of possible IP addresses that Azure storage uses. I don't know, nor want to keep updated every possible IP address that Azure storage could be. So a service tag represents all of the IP addresses. Let's go and search for storage that Azure storage uses, or it's all of the IP addresses Azure storage uses in WestUS 3. And now I can say, oh, the destination is another service tag and I would say my virtual network. And maybe I would say a specific port. Maybe I'll just do HTTPS. So, hey, I'm going to use TLS encryption to talk to the API. I want to be able to talk to storage in WestUS 3. So service tags represent sets of IP addresses that Microsoft are maintaining. So it simplifies me having to create my rules. Now you can download those. If I had my own firewall, for example, I can download a point in time and I can use those. NSGs are stateful. So in that case, if I allow the outbound to talk to the storage, I can get the response back. And as soon as I create this, I associate it with my various subnet, they would take effect near straight away. Now, as you can see here, so what I'm really doing as part of this network security group, we saw there was source, there were destinations, there's all those various things. So if we draw our virtual network again, and imagine I've got 3 subnets, getting worse and worse at drawing a subnet, but we had, maybe this is a front end subnet that talks to the internet, I've got some middle tier, and I've got a back end. So what I'm going to do is I'm going to create my network security group. So I'm going to create my NSG. Remember, my NSG is made up of the source and the destination. And the source and the destination can be an IP address range, so it can be a CIDR range, or it can be a service tag. And remember, all a service tag is, it's a set of IP addresses that Microsoft are maintaining for a particular service. I then specify the protocol, the port, so like TCP, UDP, and then the action, allow, deny, etc. And then once I've created the NSG, I associate it with particular subnets. And then it will take effect. So you can imagine I could create a whole sequence of different rules that could basically say, for example, well, the front end, the internet, is allowed to talk on port 443 to these particular services in the front end. The front end is allowed to talk to the middle tier, again on 443, it's talking to some encrypted API. The middle tier is allowed to talk to the back end on 1433, it's talking to a SQL database. But that's it. These are not allowed to talk to the internet. These are not allowed to talk directly or on any other port. So it's a way of controlling and restricting the flow of traffic. And this is just part of the virtual switch in Azure. So it doesn't really add any really huge overhead on anything. It's free. I'm not going to get throttled like maybe potentially what an Azure Firewall would need to do. So these are super powerful. You always want to be using these. When you use things like just-in-time access for a virtual machine, what it's actually doing is it adds a rule to allow the IP address. You're saying, hey, I want to RDP to my machine. It adds a rule temporarily to say, oh, okay, 3389 is allowed from my current IP address to that resource for 8 hours, and then it will delete the rule. So NSGs are actually used behind the scenes to enable those just-in-time access to resources. So that's what network security groups are really all about. I'm really working on sets of IP ranges, allowing different ports and protocols to work through. That's great until you start thinking about, well, in a more complicated environment, that starts to get really hard because maybe I've got instances of services in different subnets. They're not in a contiguous IP space. So my rules get kind of messy. So this is where application security groups come in. Think of it as a tag. An ASG is basically a tag. If we go and take a look, and just notice for a second, one of the things here I can do is specify an application security group. I don't think I've got one in this particular region. Let's do it as, I don't have any found here, but it's an option if I had any in this particular region. So that's actually a good thing to realize, that when I use application security groups, they have to be in the same region. And this time I try and say, hey, I want to add application security group. You can see I've got some because they're in this region. And an application security group is nothing more than a tag. It's literally just a value I give that lives in a certain region. So I just give it a name and it lives in a region. It's nothing more than that. And then what I can do is I can then assign that tag to a resource. So if I look at my network settings, one of the things I'll see here is application security groups. I could then tag this NIC with an ASG within the same region and click apply. So what that now means, if you think about from the bigger picture, so before my rule was all based around IP address ranges. What I can now do with this capability is, imagine I have my virtual machine and it has a NIC. What I'm creating is an application security group. So I'm going to add a new application security group, just a tag, and I'm just going to apply that tag to this NIC. Well, now, as part of the source or destination, it could be an application security group. So I could say, hey, SQL VMs can be talked to over 1433. So now I'm moving away from the restriction of it based on the IP address, which could get very difficult if they're scattered all over the place, to instead I can now just use this tagging, which is way, way more flexible for most of the things I'm probably going to want to do. Another really nice thing I can do with this as well is imagine the idea that I wanted to be able to quarantine things. Hey, I've run some rule and I've detected that this VM is compromised. I could just add an ASG to the tag that says quarantined. My NSGs might now block everything where it's quarantined except for resources to make it healthy again. So this ASG capability is really, really nice for both maintenance, but also simplifying the various things that I'm actually going to want to do. Azure Virtual WAN is really powerful for when I start having more complicated environments, or I really just don't want to be in the business of managing all of these things, the various connections, the gateways, the transitive stuff, the firewalls. It's a managed hub. That's the whole point of it. It removes you as the customer worrying about routing and VPN gateways and ExpressRoute gateways and all those routing things. What I'm actually going to do is I'm just going to deploy a virtual WAN instance. So that's a bigger resource. And then within each region I want it to be used, I deploy a particular hub. So if I think about this, how's my picture going? Where's all my stuff? Let's go over here. So we've got multiple regions. So I might think about, okay, I got region 1, I got region 2, I got region 3. And what I'm going to do is just deploy an Azure Virtual WAN. So I deploy my virtual WAN instance. And what I now want to be able to do is leverage it for things within the various regions. So what I would now say is, okay, I'm going to deploy a hub in region 1. And I'm going to deploy a hub in region 2. And I'm going to deploy a hub in region 3. So right now I've got these distinct separate hubs. And then I might say, well, okay, this hub has connectivity to this on-premises network. This hub is actually connected to VNet 1, and it's connected to VNet 2. So I define these various sets of connectivity. So these are basically peering connections between them. Great. But there's two different SKUs. And also, sometimes you'll see a secured hub. A secured hub is one where Azure Firewall has been deployed as well. But there are these two different SKU types. So what we'll see is there's basic and standard. Basic supports only site-to-site VPN. It doesn't mesh the different hubs together. It doesn't create peering connections between. There's no VNet transiting. They can be from different subscription, different tenants, but it's not doing any peering between them. Whereas standard, it supports site-to-site VPN, point-site VPN, ExpressRoute. It supports inter-hub communication. It makes the VNets transitive. It adds a whole set of different capabilities to that. I can deploy partner NVAs to the hub, like Barracuda. There's a whole set of different capabilities. But yes, fundamentally, we get very different functionalities. And it's going to come down to, hey, if I'm a more basic location, I can use the basics. I just do site-to-site. But for any larger environment, I'm probably going to want the standard SKU, especially that inter-hub and the VNet to VNet transiting through the virtual hub. Those are really nice capabilities. Being able to do that secured capabilities using network virtual appliances in the virtual WAN. As it talks about, you can upgrade from basic to standard. So if I go back to my picture, so this, for example, here, well, that could be a site-to-site. So this could be from a site-to-site VPN. I can do basic. That's the basic SKU. But now when I want to sort of go up a level, so if I want point-to-site VPN, if I want ExpressRoute private peering capabilities, if I want transitive between the different virtual networks, if I want inter-hub routing, I need standard. So standard is, hey, these can now talk to each other. These can now talk to each other. These connections could be the ExpressRoute and all those other capabilities. I could add firewall to secure these things. So it just adds a whole bunch of additional capabilities to the things I want to do. Okay. Azure Virtual Network Manager. So this is a newer component. And it's really based on, we've talked about a lot of different things. So we saw network security groups. I create it in a region and I can then link it to subnets in a region. I can create UDRs and link them to subnets. I can create peering connections. But it starts to get really difficult as you start to scale. If I have a medium environment, it's really hard to manually do all of these different routing and securing and connectivity and IP address management things. So Azure Virtual Network Manager gives me the centralized management of all of those different aspects. Now, the way it's billing is it's going to be billed based on the number of virtual networks it's managing. Historically, it's been based on the number of subscriptions that's under its scope of management, but they're moving to the actual VNets it's managing. And it also enhances functionality. So, for example, peerings, there's a finite number of peerings. When I do the connectivity through Azure Virtual Network Manager, I can actually link a greater number of them together. There's different things I can do in some of the rules, and we're going to talk about all of these. But the building block is something called a network group. So a network group is a group of virtual networks, and they can be statically or dynamically created. So if I go and look at my Azure Virtual Network Manager, so I created one already. And what I do here is I create a network group. So you just create the network group, and then you have the group members. So I have statically added, notice the source says manually added these into it, but you can also use Azure policy to dynamically add. So what this lets me do is maybe based on the tag, for example, or based on the subscription name, or the tag on the subscription, or the resource group name, or other things, it can automatically add it into a network group. So think of the power of that. The ability to, hey, as I create a new virtual network, it's in a dev subscription. Well, it automatically goes and gets added to a dev network group, because probably my dev virtual networks have certain types of communication it's allowed. It probably has certain types of connectivity. Maybe it's a certain set of IP addresses, certain routing. It can just automatically add them. I don't have to manually go and think about those. So I start off defining n number of network groups with both statically added and then dynamically based on tags and subscriptions and other things like that. Once I have those network groups, there's different things I can do. Now, the first one is connectivity. We talked about the peering options. Well, again, it gets very complex, especially that mesh. If everything had to talk to everything and I wasn't using that transitive approach, it's hideous. Well, with the connectivity options in Azure Virtual Network Manager, I have a number of different capabilities. So if you think about Azure Virtual Network Manager, there's 3 distinct models I can use for the connectivity. So the first one, I'm just going to draw 4 because fundamentally I'm lazy and I don't want to draw 100. The first one is something called mesh. And exactly as you would expect, what mesh facilitates is everything can talk to everything. But here's something super awesome here. It is not using peering. There are no peers here. If you were to actually go and look at this and look at the next hop, what it's actually done is it's created something called a connected group that I can only get through Azure Virtual Network Manager. So I will not see any peerings. It is not doing that. It's using this new construct so I can have more of these as part of a mesh than regular peerings would allow. And again, it's going to be much, much neater from a management experience. Now, the next one I could obviously do is the good old hub and spoke. This is using peerings. So here, these are peers because it's the more traditional, hey, I just want those to be able to talk to each other. But then we can add on top of this, yes, I want hub and spoke because, again, this hub might have great connectivity, ExpressRoute or services or site-side VPN. So I want these to connect to things through here, but maybe I want them to be able to talk to each other as well. Well, one of the things I can add to this is Direct Connect. And when I add Direct Connect, it adds an overlay of a connected group. Connected. It will use the peerings to talk to the hub, but when they want to talk to each other, they can just talk directly to each other. Again, it's not using peerings between each other. It's not creating this mesh of peerings. The only peerings are to the hub. Talking to each other is via this connected group. A single virtual network can be part of multiple connectivity configurations, but only 2 meshes. As soon as I create new VNets, remove them, these get updated very, very quickly. So if I'm thinking about it from a connectivity perspective, this is hugely powerful because now I'm not worried about creating all of those manual peering connections and worrying about how many peerings I can have. This will just handle all of it for me. And again, if you think about adding in those dynamic capabilities of the network groups, hey, I created a dev VNet, I created a prod VNet, blah, blah. They just automatically get added into the same connectivity setup. And there's security admin rules. These are like network security groups, but they're centrally managed and they're actually applied before network security groups. They add a little bit like a funnel. So I can think about, okay, we have our regular NSG. So this is our security capabilities. But now what I'm doing with Azure Virtual Network Manager is I create these things called security admin rules, which look super, super similar. And I'll show you one in a second. They have a few extra capabilities. I can specify ESP and AH for IPsec type things. But here's what's really cool. These normally allow and deny. Security admin rules, now remember, they run before NSGs. Think of it as this happens, then it goes to the NSG. Maybe because one of the options for security admin rules is not just allow, it's always allow. That says bypass the NSGs. Maybe I have some patching infrastructure, or it's some critical domain services. I don't want someone to mess up a local NSG and block this thing working. So if I set a security admin rule, they cannot block it at the NSG. So I can say always allow, it will always go through. Or I can say allow, and then it goes to the NSG, and if the NSG lets it through, it carries on its way. Or I could say deny, and it will just stop. So those will operate before I even get to those NSGs. So if we jump over, so let's just come out of these rules for this. If we look at our configurations, yes, as part of the configuration, we would have the option to create that connectivity configuration. So if I do create connectivity, that's where, hey, I could pick the topology mesh, where it will use that connectivity connected group, or hub and spoke. If I do hub and spoke, then I would have the option to add in. I'll just pick one of my network groups. But I could say, hey, I want direct connectivity as well, where it would do that overlay connected group. But I can also create a security admin configuration. And the security admin configuration is just made up of rules, which will look super similar, except when we look at the protocols, we also have ESP-AH. We have the any there. And as part of our action, we have always allow. So it doesn't care what the NSG says. So we just have those extra sets of capabilities. Now, some of the other things it does is, for example, I can do user-defined routes. So one of the capabilities it could now do is I have the option of creating a routing configuration. So I can have multiple routes that I define, and then it will apply it to the network group and then all the VNets in that network group. So that's a nice capability. Also, I can do IP address management, IPAM. Managing the IP space can always get quite complicated. You have to make sure they don't overlap, or I've got this many, where am I? So with Azure Virtual Network Management, I tell it all of my pools of IP addresses, and then when I go and create virtual networks, it will assign the IP address space from the pool that I configured in Azure Virtual Network Manager to ensure, hey, they're not overlapping, but I'm using an optimal use of my IP space. So think of this as that core set of centralized at-scale management of those key attributes that I think around networks. So I want to talk about service endpoints and service endpoint policies. Network security groups, remember, are focused on the flow of traffic within the virtual network and out and into the virtual network, which is fantastic. We definitely need that. But it doesn't really focus on the idea of like a PaaS service that exists that's not in our virtual network. And I want to control what can talk to the PaaS service. That's not something that an NSG typically is going to help with. There's a few things we can do, but it's not typically going to help with that. So I'm going to think now about the scenario where, let's draw yet another virtual network. So I'm going to have my virtual network. So I've got my VNet. But now what I'm going to focus on is, sure, there's a subnet inside it. I'm just going to draw one subnet for now. But now I've got some resource. Maybe it's a particular storage account. It's storage account 1. Now, one of the things that nearly all PaaS services have in Azure is they do have a firewall. So they have a firewall configuration. And there are things I can do in that firewall. So I can say, hey, only allow talking to me from certain IP addresses, which sounds great. Okay, I'm going to say, hey, from this firewall, only allow the IP range of this subnet to talk. That doesn't work. Now, the reason it doesn't work is, remember, your virtual network is made up of a non-routable IP address range, which means when it talks to the storage account, it's not using its normal native IP addresses. It won't see that. It would see whatever that NAT address is that it's using to talk to the internet. Now, the traffic doesn't bounce via the internet, but it's still the IP address that the storage account would see. So I can't just say, well, let this subnet go and talk to this particular service instance, because it doesn't see it. It's not going to work. So a service endpoint makes a specific subnet known to a particular type of service, like storage, and it establishes a specific path. So it's doing two key things. So what I can do now is, for this subnet, I'm going to say, hey, I'm going to add a service endpoint for storage. That's now going to do two things. For things in this subnet, only for stuff in the subnet. So for stuff in the subnet, I'm now going to get an enhanced routing. So it's not going to try and bounce out to the internet or that regular route. And this subnet in this VNet now becomes a known quantity. So I can, on the firewall, say, oh, VNet subnet, do I want to let it through or not? I'll say, oh, yes, I will. So it's a two-stage process. I enable the service endpoint. So if I go over to my storage account or manage database, many different things support service endpoints. But I'll go to a storage account. I'll pick a storage account. And if I go to my networking, one of the things we'll see here is I can enable from selected virtual networks and IP addresses. And one of the things you'll now see is I can add an existing virtual network. So I can click Add. It will show me all of the different virtual networks. I could select one of them, and that will show me all the subnets. Now notice it's saying a service endpoint is required. I've not created the service endpoint yet, but it could actually go and create it for me. But then it would enable just that particular subnet to be able to talk to me. Now I can also manually on the virtual network enable that. So I go to the virtual network. Come on. I go to the virtual network, go to my subnet, select my subnet, and then we will see service endpoints. And I would just select the service that I want to enable service endpoints for. So I could say, oh, storage, for example, and hit save. So that would be known, and I could now enable and restrict that for that subnet on that target storage account. So it helps me now on the services, my PaaS services, restrict it to certain virtual networks. So that's a good thing. So now I can go and do that configuration we saw. What it doesn't help with is data exfiltration. So data exfiltration is the scenario that, well, maybe I'm a resource in here and I'm allowed to talk to service account 1. That's great. I'm restricting it to only things in this subnet. But imagine there's another evil storage account, because I'm a bad guy. So what I did is I created storage account 3. And what I intend to do is I'm in here, I connect to the proper storage account that I'm allowed to do. I'm then going to copy and write the data to another storage account. Well, that would be a problem. So one of the things service endpoints let us do is once I've got it enabled for the service endpoint for storage, I can then go ahead and I can something called a service endpoint policy. And what I'm going to say here is I'm going to allow storage account 1 and storage account 2. And then I'm going to associate that service endpoint policy with this particular subnet. And you saw it when I looked at the subnet, there was that option for service endpoint policy. Well, what that would now do is when I now try and talk to storage account 3, it'll be blocked. So now there is no data exfiltration. So that's a really nice capability to help protect me from those things. Now, one of the challenges is service endpoints is not getting a huge amount of investment today. It's very much private endpoints we're about to talk about is the more preferred. It's getting a lot of the investment in those things. But just so you can see it, if I look at my service endpoint policy, there we go. The key point here is I can just specify the specific services. So right now this just has one included in it, but I could go and add other instances that I want to be part of this. Notice it's only for storage. I could add a particular resource that would now be allowed as part of this policy as well. And then I associate it with the subnet, or I could do it at the subnet directly. So it's a way to just restrict and lock those things down. Okay. I've used the word private link quite a few times. So let's talk about private link. Most Azure PaaS services have a public endpoint, so an internet routable address. Now, there's firewalls in front of it. We always have authentication in front of it. Barely ever is it open. It's always locked down by default. And if I do talk to that public endpoint from an Azure resource, it doesn't hairpin via the internet. It will stay on the Microsoft network. However, we may not want that. I may not want to even talk to a public endpoint. I may not want that public endpoint enabled at all. I want it completely unavailable. So, Private Link enables those PaaS services to have an IP address in our virtual network, our subnet, that represents a connection directly to that specific instance of that service. So now I could think about, okay, let's create another storage account. So if I create, what number are we on now? Storage account 5, just play it safe. So if I've got storage account 5, and by default, right, it has a public endpoint, which is what we would talk to, but we want to turn that off completely. So what we're going to create is something called a private endpoint. So the private endpoint is just an IP address from the subnet where I create the private endpoint, but it talks directly to a particular instance of a service. So that's the key point around this. So now I talk to this IP, I'm talking to that service. And because it's an IP address, it will work for anything that can talk to this IP. So other subnets in the VNet, peered VNets, on premises that's talking to site-to-site VPN or ExpressRoute private peering, I can just use it from anything. So that's a very nice capability. Hey, if I can talk to the IP, I can use this thing. And I can use it for all manner of different services, storage, SQL, Cosmos, managed. Pretty much private endpoint is the direction forward. Nearly everything can use it. However, think about when we talk to resources. Do we talk to the IP address? Well, yes, we do, but we don't actually initially talk to the IP address. There's a name for it. And that name is what we use for the encrypted communication. So there's going to be a DNS name, and the name we use has to match that of the service, because that's what the certificate would be mapped to do encrypted communication. Now, ordinarily, if I look at, let's say this is storage account 5. So storage account 5 would be called storage account 5.blob.core.windows.net. And that would resolve to the public IP, which we've now disabled. And we could see this if I go and look at my storage account again. If I look at storage, and we'll just pick, where's my storage account 10? My storage account 10, and we'll look at my endpoints. I can see that's exactly what I have. Storage account name.blob.core.windows.net. That's what I would go and talk to. And that would resolve to the public IP address. Fantastic. In fact, if I go and look at it, we can see there's public IP address that talks to the storage stamp where my storage account exists. But there's also something a bit weird. There's the name that I'm used to, but there's this weird other version that has private link inserted in between the storage account name and the blob.core.windows.net. Because what I've done on this particular storage account is I went ahead and I added a private endpoint. So this storage account has been enabled for a private endpoint into one of my virtual networks. Think about what we need to happen here. I have to match the name. I can't just talk to the IP address. I can't just talk to PE1 because then it's not talking to the qualified domain name. The certificate on the service would not match, and I can't do an encrypted communication. So when we enable private link, what actually happens is it creates another alias, which we saw there, which is the name of the storage account, .privatelink.blob.core.windows.net, etc., etc. And this is going to resolve to that IP address, PE1. Now, how? I want to talk to this. I have to be able to resolve when I talk to sa5.blob.core.windows.net. It actually resolves to this private IP address. We have to modify the DNS configurations. Now, this all sounds very complex. The good news is, and we're going to talk about this actually next, but we have something called Azure Private DNS. So what we're going to do is we're going to have a private DNS zone called privatelink.blob.core.windows.net. And what's going to happen is we can integrate private link with private DNS zones. So when I create this private endpoint and it gets this name, it can auto-register. So it's going to auto-register if I enable the integration. So it's going to go ahead and create storage account 5 in this private link.blob.core.windows.zone. And then I link this zone to this virtual network. So now I will get the name resolution I need. So when I look up sa5.blob.core.windows.net, it will actually say, well, actually, there's an alias, .private link. It will then, because it's connected to it, look up the private link zone that's mapped to it, which will now resolve to this IP address, and I'll be able to talk to it. But it's the correct name, so I can get that encrypted communication. Now, what this does mean, if I'd a peered VNet that also wanted to talk to this, it has the IP path to PE1, but it also needs the same name resolution. I would have to also link this zone to any other VNet that wants that same resolution. If I want to talk to it from on-premises, well, I'd either have to create this record in an on-premises zone or use something like Azure Private DNS Resolver that it could forward the request to do the resolution. So the key part here is private link itself is super easy. It's the DNS that often will complicate things. So if I say, okay, so there's this private endpoint. As part of this sort of configuration, I have got it mapped automatically. So you can see that's the IP address that it has within the virtual network that it's mapped to. And I have linked it to a particular private DNS zone. So if I was to now look at private DNS, I have a private DNS zone, private.blob.core.windows.net. If I look inside that, you'll see there it is for my storage account 10 that talks to that IP address. If I actually looked at my virtual net, and you can see it's bound to my particular virtual network where I create the private endpoint to. If I actually looked at that virtual network, actually I'm just going to look at the virtual network directly because this is not doing what I want it to do. But if I was to look at connected devices, one of the things we can see here is the private endpoint. So we can see it actually as a virtual NIC. If I then went inside a virtual machine that is connected to that, and I do that same NS lookup, notice what it now resolves to is that internal IP. And it's using the correct, namely it's using that alias, but I would now be able to talk to it through that private endpoint. So it's kind of a little bit long. It's kind of a little bit, it seems convoluted. I totally get it. That's the complicated part of private link. It is not the private endpoint itself. It's realizing all of that DNS configuration that you have to have as part of it. It's just that is what it is. And also because this is instance specific, it will help stop that data exfiltration because I can only allow communication to those ones I have. Now, there is actually a feature, this can make it even more complicated, called internet fallback. So imagine I have this storage account that I have private endpoint for. So because of that, I have to have this private link.blob.core.windows.net linked to my zone, my virtual network. Now imagine I want to talk to storage account 6. Now storage account 6 actually has a private link as well, but in a different VNet completely. And actually, it's using a different copy of this zone. I'd have multiple of them with the same name. So when I try and talk to storage account 6, well, I see that there's a private link alias, and I try and do a resolution. Well, my copy of that private zone doesn't have storage account 6. So it will respond with a non-existent record. So I'll give up. That's maybe not what I wanted. Maybe I left the public endpoint open for storage account 6, and other things should just use the public endpoint. So on this link, I can turn on internet fallback. And then with internet fallback, what it's going to do is instead of just responding with the non-existent domain, it will go and use the public DNS resolver to see if that can resolve it and then give me that response instead. So that is a capability that is available. And that's actually a very recent thing. So if I was to look at my that private DNS zone again, and I look at my virtual network link, notice fallback to internet, and I've got it enabled. So if I did try to access a storage account that has a private endpoint, but to a different VNet that has a different copy of that private link.blob.core.windows.net, instead of just responding to me with an NX domain, can't find it, it will go and use the internet resolver, so I should now still be able to get to it. So nice capability. The other thing I can actually do is I can expose custom services to it. Remember I talked before about the idea, well, what if I had another virtual network that maybe had an overlapping IP space, or I just didn't want to peer them. I don't have that relationship. Maybe it's a customer. I don't want to peer them and have full IP routing between them. So one of the things I can do in here So imagine I have a set of resources. I have put them behind an Azure load balancer to provide resiliency for them. I can create a private link service instance, and then I can create a private endpoint in a different subnet that points to it. Remember, private link is doing network address translation, so these could have overlapping IP ranges. It would not matter. Don't have to be overlapping. Again, private endpoint is fantastic in that, hey, I just don't want to peer these. Maybe this, again, it's a customer. I just want to expose a certain service. I can do that with this. And I can mix service endpoints and private endpoints in the same subnet if I wanted to. Again, remember the nice thing is service endpoints are free, but it only works for the stuff in the subnet that has the service endpoint. Private endpoints I pay for, but they're going to work for anything that has a path to the IP address. Peered VNets, ExpressRoute, private peering, sites like VPN. But it does have to be able to do consistent name resolution. So that adds a little complexity to how I think about that. Most companies today, honestly, private link is the direction of things that are going. So as I mentioned, this removes the need to peer if that was the only reason. Final thing, DNS in Azure. DNS is critical to nearly everything. Most of the times there's a network problem, it's blame DNS. Because remember, DNS is about, we're not good with IP addresses, and we don't like to use IP addresses because I want to be able to maybe change the IP rather than to reconfigure services. So we like to talk to a name, and then the name resolves to an IP address. And DNS is the solution in a hierarchical fashion to let me resolve a name to the IP address. So it's a very powerful capability. And Azure has DNS services. So Azure has a native DNS resolution. It's the default for virtual network. So it will go and resolve various names that I want as part of my IP. I can change the DNS config of a virtual network. I could point it to maybe my own DNS service. It could be domain controllers, for example. I can absolutely do those capabilities. And it can provide both public and private zones. So now both of these are global resources. So what that means is they don't just live in a region. I could create a public DNS zone. I can create a private DNS zone. And then I could link a private DNS zone to regions and VNets in regions all throughout the world. So they are global resources. For the public, I can create all the regular records, the host record, the A and the quadruple A for IPv6. I can create CNAME records. There are other types I can do. But this is where I want to have name resolution for things via the internet routable DNS system. Now, what I would have to do is obviously set up Azure DNS as authoritative for the zone. I can't just go and create a public DNS zone in Azure and expect it to work. It's a hierarchy. So if I created ntfaq.com, I have to go and tell the .com registry, oh, if someone's asking you about ntfac.com, send them to these DNS servers, it would be the Azure DNS servers that are authoritative for that zone. Now, additionally, instead of just manually creating all these records, one of the really nice things is some services will integrate with Azure DNS. Now, because one of the challenges you can actually face with DNS is, especially alias records, like another name for, maybe I create on my DNS servers the idea that, okay, imagine the sequence that there's some Azure resource. This Azure resource actually has a certain IP address and it has a certain name. So maybe it's sort of I'm just going to make up a name, appservice.azure.com, blah, 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 blah. It's something that Azure just assigned. I don't want to use that publicly. So what I do is on my DNS servers, I create an alias, and maybe it's like www.mystuff.com, whatever that might be. And I create that as an alias. One of the challenges could be, imagine you then delete this service. So I'm fed up with it. I'm done with it. So I delete this, and I kind of forget that I left this record out there. Well, it's now called a dangling DNS. This points to something that doesn't actually exist anymore. And what can happen is the bad guy could come along and use the same name. They're going to create app.appservice. Because you've deleted it, .azure.com, well, your record now points to this. And now the bad guy can do bad things, devil, because this resolves to them. Now, there are many Azure services that do things to try and protect from that. But one of the really nice things Azure DNS does now is many services will integrate directly into public DNS. So if I was to look at Azure DNS, where's it gone? Why is it not showing me that? Let's just search for DNS. There we go, DNS zones. So these will be public zones. So from here, I don't know which one I've got, but if I look at onboard to azure.com and look at my record sets, now there are ones that I've manually added in here, blah, blah, blah. But there are then these interesting ones like learn dev. They're an alias, but they're an alias actually to an Azure resource. So what's happening here is these are directly tied to an Azure resource. I'm not having to manually go and configure this. So now, because it's tied to the Azure resource, if I was to delete the Azure resource, it will delete the record so someone can't go and steal it from me. So wherever possible, avoid just doing an alias to another name. If it's an Azure resource, go ahead and use the service integration. It's a much, much better option for you. So do that where you can. You can also do private zones. So obviously a private zone, I'm going to create the zone. I can use any name I want because it's not publicly usable. I can manually create records, full range of different record types, A records, C names, MX, pointers, SRV, SOA, TXT, because it's just an internal. I have full manageability of that. I can really create whatever I need in that. Records can manually be created, but they can also be automatically created by different types of resources. So one of the nice things is a virtual network is linked to private DNS zones, but it can have one of those private DNS zones used for resolution purposes. So the idea here is, if I think back to this picture for a second, what color haven't I used yet? I'm running out of colors. I've actually run out of colors. I don't know. That one. So imagine I create a private DNS zone. Some name, something, dot, whatever I wanted it to be. I always then go and link this, remember, to virtual networks. Now, a virtual network can link to up to 1,000 private DNS zones for resolution purposes, because they're all different. Private link.blob, private link.data lake, queue, table, Postgres, whatever custom name, loads of them. And a single private DNS zone can be linked to up to 1,000 different virtual networks. But additionally, a virtual network can link to one and only one. This is in my way. Let's move no data exfiltration out the way. Go over there. Okay. So it can link to one and only one for automatic registration purposes. So what that says is that I create resources in this virtual network for one name, it will go and create records in the zone for the name of the resource. So I create Bob in here. It would go and create Bob dot whatever that private DNS zone was. And a private DNS zone can support up to 100 different VNets. They're allowed to auto-register to it. So I have those sets of capabilities. So many private DNS zones can be used for resolution from a single virtual network. And one private DNS zone, it can be used to auto-register resources from that virtual network. So those are the things I just talked about. Again, it is a global resource. I can use it from any region, any subscription, any VNet, any tenant. I just need the permission. There's one other element, and it's the Azure Private DNS Resolver. And this has two different benefits. There's going to be scenarios where, okay, great. I have these private DNS zones that I've linked to my virtual network. But I might have on-premises networks that have DNS services. They want to be able to go and resolve things in those private DNS zones. Maybe it's like the private link stuff. They can't. I can't link and talk to private DNS zones. So one of the things that Private DNS Resolver does, it does two different things. But one of the things it does is it uses different subnets. So it's got sort of two different sets of endpoints that it leverages. But one of them is it can provide like a target IP that other DNS services can use for resolution, and it will then go and talk to the Azure DNS resolution, and all of the private DNS zones linked to it would now be able to return the records to the DNS. It's also a way for Azure DNS, so if I've got things talking to Azure DNS, to go and query other DNS servers for forwarded zones. So it has another endpoint that Azure DNS can now say, hey, we've been configured to talk to saviltech.net to some DNS server over here. It has a path to it and can go and get the answer and give it to Azure DNS. So it can run in both of those directions. I can use one or both of those services. Again, each of them need their own subnet. I think it's a /28 for each of the subnets. You can link the Azure DNS Resolver to multiple different subnets, and they don't all need the same sets of connectivity. I can leverage, as long as one of them has the endpoint to go and resolve, it could do it on behalf of other subnets that Azure Private DNS Resolver has been linked to. It's just going to use that one. So that's a very nice capability that is included that you can go and deploy. And that was it. So lots of stuff in networking. Networking is fascinating. It's always growing. But I hope that was useful. Until next video, take care.